At the very heart of this decentralized shift is the IPTV-ORG project. Think of it as a massive, centralized clearinghouse for global media. It's incredibly active. Right now, the community is indexing over 8,000 publicly accessible, high-definition broadcast endpoints. And these are coming from hundreds of different jurisdictions all over the globe. It's just a continuous, massive influx of crowdsourced data.
But here's the wild part. Despite routing all of this massive global internet traffic, do you know how many video files the project actually hosts, encodes, or retransmits? 0. Literally none. It operates strictly as a highly structured, machine-readable metadata index. All it's doing is validating and serving pointers to remote URLs that broadcasters have already intentionally put out there on the public internet. So it's a routing manifest, right? It's not a content delivery network.
And that distinction, that creates a massive paradigm shift. Think about your legacy commercial networks. They rely entirely on monolithic, provider-controlled hardware and these heavily encrypted data streams. But in the decentralized IP routing ecosystem, it's all about a modular, microservice-like hierarchy. You are the one taking control of the metadata, the JSON and M3U files, and you're leaning on client-side decoding. You are completely untethered from a single provider's hardware. You control the routing.
Now, to build out this architecture, you absolutely have to separate the actual video payload from its navigational metadata. It's like a two-part puzzle. On one side, you've got the M3U manifest. That's your raw video payload, basically just a huge unorganized list of channel links streaming from a directory. Then, on the other side, you have the XML-TV format. That acts as your electronic program guide, or EPG. This is where your temporal scheduling data lives, all your current and future programming blocks. So raw video on the left, schedule on the right.
So how do these two completely different files actually talk to each other? Well, that happens through what's called the TVG ID. Instead of using some random, complex cryptographic hash, the maintainers went with a standardized semantic naming convention. It usually just mashes together the channel name and its broadcast country code. This acts as your primary foreign key. When your media player reads that M3U video stream, it caches that specific ID, cross-references it against your imported XML schedule, and boom, that's how it generates the actual graphical interface you click around on.
In the real world, if you're using a self-hosted companion app like Stationaire inside a Docker environment, you can set up a completely direct pipeline for this. It's a simple three-step process. First, you import your raw M3U playlist. Second, the system automatically matches those channels to your imported XML TV guide data using that exact TVG ID we just talked about. And finally, step 3, it serves up a super clean, customized playlist directly to your local IPTV player.
Of course, processing all this data smoothly requires a seriously robust management layer. Parsing global TV schedules means chewing through massive XML files, a lot of times well over 100 megabytes. To keep your server's RAM from completely spiking and crashing the whole system, this architecture uses a highly memory-efficient SAX streaming parser. It then builds a background SQLite guide index, which means your TV guide queries load almost instantly. And right before sending that data to your player, it outputs a gzip compressed EPG. That literally shrinks the network transfer size by about 90%, letting your player's interface populate in milliseconds. It's insanely efficient.
Now, relying on third-party, public EPG websites, that introduces some major risks. Think caching delays and server timeouts. But advanced engineers bypass this single point of failure entirely by automating the whole thing with Docker. By deploying Node.js scrapers via daily cron jobs, you are autonomously fetching your own guide data straight from the source. You synchronize the metadata entirely within your local network. It makes your setup practically bulletproof.
Okay, real quick, a crucial troubleshooting tip if you're setting this up. When you go to spin up that sidecar scraper, you absolutely must create an empty channels.xml file in your mounted volume before you start the container. I can't stress this enough. If that file isn't there when the container initializes, the scraper will just flat out fail and throw your entire system into an endless crash loop. So map the file first, then spin it up.
Once your server is humming along and crunching all that metadata, how are you actually getting it to the client? Well, loading a standard M3U link forces your media player to download and parse the entire massive database all at once. We're talking every single channel, movie, and guide entry. On lower-end devices, that's a one-way ticket to Crash City. But switching your player's connection to the Extreme Codes API fixes this completely. It breaks the data down into structured fragments. It only queries the live TV, video on demand, or EPG categories exactly when you ask for them, which massively speeds up your load times.
So your metadata is perfectly synced via API, giving you this flawless, snappy interface. But to get playback that's just as smooth, especially if you're watching 4K sports, you've got to configure your player to use hardware decoding. Specifically, you want media code surface. What this does is take all the heavy lifting of video decompression totally off your device's primary CPU and hands it straight to the physical graphics chip. Do this and those annoying microstutters and frame drops? Completely gone.
But listen, all the hardware decoding in the world isn't going to save you if your network itself is the bottleneck. The operational reality of live IPTV is that it just can't buffer minutes in advance the way Netflix or YouTube does. For true 4K Ultra HD streaming, your local network has to sustain a continuous, unthrottled download speed of 25 to 50 megabits per second, period. Seriously, hardwire your primary viewing devices with Ethernet whenever you can. Wi-Fi packet loss is the absolute worst enemy of live video streams.
So there you have it. You now have a complete understanding of exactly how this ecosystem operates. This isn't just some basic plug-and-play consumer gadget. It's an advanced routing manifest and metadata framework, and it heavily rewards meticulous engineering. By controlling your own payloads, parsing your own schedules, and optimizing those client decoders, you can build an absolutely unparalleled pipeline to global media. You've got the blueprint. So is your media stack going to stay locked in the monolithic past, or are you ready to build the decentralized future in your own home lab?